Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at software engineering, and for this session I will be discussing on software project management, which is the continuation of what we have seen earlier. So, in this particular session we will be looking at what crush would mean and a term which is called an indirect cost and how to estimate the total cost for given a project. Till last session what we have seen is how would we reduce given a particular project. Say in case a particular project is need to be crushed, say for a minimum duration as specified by the customer, what would be the extra expenditure that would be incurred. So, as we have indicated earlier, as time decreases, cost thereby would increase in terms of development, but here again we have introduced another term which is called as an indirect cost. So, indirect cost is something that we might take it as a overhead, which is something like I might have rented few equipments for use of this project. Say I might have rented a desktop PC, I might have rented an infrastructure basically required for utilizing these desktop PCs and other things. So, when time comes down, the indirect cost also would come down, whereas the direct cost, that is the wages and the salaries that are to be paid to my employees, would be increasing. A given list of activities. So, this is something that is what we have seen in the last class. A, G, H was a list of A, C, D, G, H was a list of activities that we have indicated earlier. But after looking at some other critical path of B, A, G, H being common, B and C, B and D. So, any change that I would want to indicate would reflect on B and C together, B and D together. So, what I would indicate here is what is the next step that I can take it up out of these two activities. So, the optimized cost being A. So, A taking up only 2000 rupees per month per week and can be reduced to a maximum of 3 weeks, whereas when I consider B and D, it takes up 7000 per week and would take a maximum of 2 weeks. So, when I do it for 3 more weeks, the total cost incurred would be 6000 on a whole. So, now looking at this particular diagram, any impact that I have on A would give the impact on the total flow of the diagram, and if I reduce A by 1, the total duration would reduce by 1. So, how about the other flow? Being this also as an alternate path, will this impact? So, that also we may have to note it down. So, if I reduce A by 1, see the total duration would be 20 weeks. If I flow through this path, say 14 plus 6 would be 20 weeks would be the appropriate time. So, the impact would be on all the 3 flows, that is A, C, D, G, H, A, B, G, H, and other flow which is E, F, H. So, now all the 3 flows would be considered as my critical path, which makes the entire network diagram very complex. So, when we look at the overall table for this particular project, when I have the entire activities, I have defined this step by step in terms of the various crashes that has happened, the project duration, how much it has got reduced, the total extra cost required for decrease of one specific activity, and total direct cost that got increased, and total indirect that got decreased, and the total cost, which is the sum of direct cost and indirect cost. When all the activities as mentioned by the customer and the plot done by the project manager was done, the entire duration was 30 weeks, which involved no additional cost, but then the total direct cost would have been 93,600, which I would have indicated in the table, and the direct cost, indirect cost, that is by incurring rupees 2000 per week as a rent. If I would pay for a list of activities, then 2000 into 30 weeks would be 60,000 rupees. So, as a total of 93,600 plus 60,000, which will be 1,53,600 will be the actual cost that I would have spent per week. Now that after crash of G by a week, my duration got reduced to 1 week, that is 29 weeks, whereby the extra cost for reducing that to one more week would have been 400 rupees. So this would indicate on the total direct cost. So 400 should be included on the direct cost. So it becomes 93,600 plus the 400, which will be 94,000. Whereas the indirect cost, I am not trying to utilize this for that particular week. So that would obviously get decreased. So this will be per week, it will be 2000. So I will decrease 2000 from this amount, which will be 58,000. So the total cost would be 1,52,000 only. Again, I do an impact on crashing this particular activity by one more week, which will improve on the cost by 400, thereby it becomes 94,400, and the total cost got reduced from 58,000 to 56,000 here, and this total cost will be the addition of these two things. And when I am to crash B, the project duration got reduced by 4 weeks, that is I am to crash B by 4 weeks. So per week I incur a cost of 1000 rupees. For 4 weeks it will be 4,000. So this cost need to be added to this 94,400. So that will be 98,400. So for 4 weeks it will be 2000 into 4, which will be 8,000 rupees, which should be reduced from this 56,000, which will be 48,000. 98,400 plus 48,000, which will be 1,46,400. Again, if I am trying to crash B and C together by a week, that might take an extra cost of 1,400. So 1,400 to be added to 98,400, which will be 99,800, by where the indirect cost again will get decreased to 2,000. So the sum of these two, 99,800 plus 46,000 will be 1,45,800. If I am trying to reduce H by a week, it will take a cost of 2,000. So this 2,000 need to be added to 99,800, which will make it 1,01,800. So this cost will come down by another 2,000, which will be 44,000. So 1,01,800 plus 44,000 makes it 1,45,800. And by crashing A, I will get, with the same procedure, I will get 1,40,800, and crashing A and E together for 20 weeks, the cost would be the same. So one interesting thing that you can note here is any reduction after, see, as far as project management is concerned, what we are aiming at is reducing the time and reducing the total cost for a given project. As far as this table is concerned, I have reduced the time from 30 weeks to 20 weeks. So I can promise my customer saying I can reduce it from 30 weeks to 20 weeks, which is 10 weeks possible time. But then when I look at the cost, until 23 weeks the cost got reduced meagerly, whereas after 23 weeks any certain reductions from 23 to 20, the cost remains the same. So in that particular juncture, for beneficial purpose from the developer's end, developer would give them a sufficient feel that the project can be reduced from 30 to 23 weeks to the maximum. So this 7 weeks would be the appropriate time for any developer who can have an appropriate costing factor. Any certain reduction after this, say 23 to 22, 22 to 21, 21 to 20, will not impact on the cost. So he might not bother about any certain time reduction. So the major impact would be on 1,45,800, which happens at 23 weeks duration. The developer will promise the customer saying, if suppose the same product has to be delivered within the time, then this can be reduced from a maximum of 30 weeks to a minimum of 23 weeks, which will be entertained. So from this particular table we get a clear understanding of given a specific project, the project will be complete in 30 weeks with a total direct cost of 93,600 as specified by the designer and with an indirect cost of 96,600, but with a mention to the customer it will be to a total value of 1,53,600 per week. Whereas when the customer asks, say, if it can be reduced to 24 weeks, the total cost will be calculated here. The customer can even post a question of, can it be brought down to 25 weeks, so something in between. So since that we have directly reduced from 28 weeks to 24 weeks in terms of B, we have not indicated 25 here. If suppose we can roll down all these details, so we can extract between G and B and we can plot a value of 25 here and show the customer how much would it cost if I am to reduce it to 25 weeks. After the plot of this kind of a network analysis diagram, we were in a position to identify the overall schedule of the project, the overall planning for the project, that is the dependencies and the relationships that I have between one or more activities, and schedule was about to calculate, that is the total duration that is required for plot of this kind of a network analysis diagram, and controlling where how much can it be reduced. If in case it get reduced for this week, what would be the total cost? If in case it has to be increased or the project has to be dragged to 2 other weeks, what would be the total cost can also be calculated. And we have utilized the entire definition of project management, where we have said on time, within budget and with the total technical specification as mentioned by the customer. So all this has been brought in one certain table, which would clearly give us a picture on what a project will do. Now this problem has got the first 3 activities without any prerequisite, and the next set of activities comes with a list of predecessor activities. Now that we will look at how we can draw the network analysis diagram for this. This is the start of the project. As I have mentioned, this event will be the start of the project. Since A, B and C does not have any predecessor activity, it can start at the same time. So this I will mention it as A, and this will be B and this will be C. To start with D, C should be complete. So somewhere C will be complete, then I start with an activity of D. To start with E, B and D together should be complete. So B is not the only activity that has to be complete. B and D I am closing it together, that makes it the beginning of E. F starts after completion of A and E. So A and E putting together will have F. G is after A and E, but I have started F already. So G is also after A and E. So these 2 activities are in parallel. H is after B and D. B and D is here. H is after B and D. So E and H are done in parallel. I is after F. I is after F. Now this, as I have told you, for a network analysis diagram to be complete, the project should have only one start and one end. Now that you see 1, 2, 3 ends are there, so which we will make it as a point to combine all these 3, which will be the end of the complete work. So this represents clearly the network diagram. I repeat, first 3 does not have any prerequisite. So I have started with these 3 activities in parallel. D is after C. So C is supposed to be a predecessor activities, then only I start with D. E represents after B and D. So B and D getting joined, then comes E. F is after A and E, A and E, after which I get F. Likewise G is also after A and E. So I draw F and G concurrently. H is after B and D, B and D joining together, but before E got started, now H got started parallelly. I is after F, I is represented after F. So, for completion H, G and I putting together makes the project complete. Now, to this network diagram, we will consider another point which will be the normal time and the crash time. So, the normal time that I have represented here are 30 weeks, 25 weeks, 10 weeks for individual activities. So, this will be for A. So, this time is for A and this is for activity B and this is for C, likewise it goes. So, A takes up 30 weeks, B takes 25 weeks and C will be 10 weeks, D will be 10 weeks, E is another 10 weeks, H is 20 weeks, G is 35 weeks, F is 20 weeks and I is 20 weeks. For this I may have to calculate the total time required. So, as I have told you, every node will have early start and early finish time. Early start, early finish, late start and late finish timings. So, if I start at 0 at for the activity A, B and C, when will I complete A? So, I will reach here somewhere at a point of 30. So, I may reach here by 30 weeks, but that is not the right time I am to mention, since one or more nodes join here I am taking it off. So, A takes 30 weeks is plotted here and I remind it as 30. B takes 25 weeks to reach this particular destination, but one or more activities merge, so 25 is being written down, and C takes 10 weeks, so that is the only activity happening, so I reach here by 10th week. From here I take another 10 weeks to reach to this place, so which takes a total of 20 weeks. Of these, in the forward pass I have said, during the forward pass we consider the maximum of time, so reaching here would be on 25 weeks. From here to here it takes another 10 weeks, so 25 plus 10 I will reach here by 35 weeks, but that is not the only node, I can come across A also. So, 30 and 35, now I look at which one is the highest, so 35 will be the highest time that I will be considering. So, after which F starts and takes 20 more weeks, so I will reach this place at 55 and I will take to the destination. The total time would be 55 plus 20, either it could be 75 or I will have 35 plus this 35, 70 or 25 plus 20, which would be 45 weeks. So, the maximum of these three would be 75 weeks. So, I will reach this particular place at 75 weeks, which will be the completion, overall completion time for project would be 75 weeks. So, now that if I am to complete this project in 75 weeks, if I am to complete the project in 75 weeks, when should this be complete? So, that procedure I will try to do it in the backward pass. So, wherein I will consider the minimum time. So, when I am considering the minimum time, 75 minus 20 will become 50 here and 75 minus 20 will reach here by some time and 75 minus this loop will take me to some time. So, from this kind of a workout, what I will be getting is which is the actual critical path that I will be transferring through in the all the networks. So, now look at the independent paths available in the entire network diagram. The independent paths are A and F and I, or B, E, H or B, E, F, I. The other path would be C, D, E, F, I or C, D, H or C, D, E, G. So, although there exist so many independent paths, but certainly one of the paths must be a critical path. So, now that our intention is to identify that particular critical path, and to proceed to next set of stages. So, as a next stage, what we will be doing is, we will be considering the normal time. What would be the normal time that every project cost? And if suppose the customer asks me to crash the entire activity into a list of timings given, so that means A can be crashed by 5 weeks, B can be crashed by 5 weeks, and C can be done in 2 weeks, and D can be in 3 weeks. Likewise, certain other activity can also be crashed. If such is the case, what is the crash time that is required? So, this is a simple calculation that we have seen as part of network analysis diagram and project management scenario. On top of what I have explained to you, I have included one more thing which would indicate on the cost, which is if the variable overhead costs are rupees 50,000 per day, determine the optimum duration. So, this is the column that I have included on top of what is existing. Say I have given you a normal cost and I have given you a crash cost also. By the workout on a crash cost on a critical path, we are able to estimate which activity reduced by a day or a week would give me an optimized path, and how far it will vary from the normal cost to the crash cost. So, by way of doing this particular crash cost, how much it got changed in the optimal duration can be easily calculated, and on top of it, as an indirect cost, I have included rupees 50,000 per day. So, now this crash cost plus indirect cost would give me the total cost required for completion of this kind of a project. So, on top of what I have explained on this problem, the previous problem was mentioning on a point of reduce it to a maximum duration possible. Now, what I have mentioned is a point of rupees 50,000 per day, and say for example to the actual duration that is available. Say in this particular problem we have calculated the maximum duration as 75 weeks. So, in that 75 weeks, if suppose by not looking at the critical path, the customer asks you to reduce to 70 weeks or 65 weeks, what would be the optimal cost that you require for the project to be complete and successful? That also can be efficiently calculated. Summary: in this particular network analysis diagram, by use of this particular diagram, every project manager will get a clear indication of how effectively this kind of projects can be planned, how these can be scheduled, and how it can be controlled. In case of riskful scenarios, how these projects can be handled. And as an extension to it, I have indicated to you the normal time that is required to complete the project, and the crash time, that is a product that is to be delivered beforehand or before time, so that this will reach the market on time. That timing would be on the crash time, and how this would reflect on the cost. The time would reflect on the cost and the crash time would reflect appropriately on the crash cost. So, by this network analysis diagram, you are clear with what would be the appropriate time every customer would expect on the product, what would be the approximate cost in case of a reduction on the time, in case of increase on the time, and things like that can be easily figured out. So, some of the questions for this particular session: what do you mean by indirect cost? Who will indicate the difference in time? How much can this time be reduced in the total time? Thank you.